What is the first shifting theorem? So in Laplace transform, we come across the first shifting theorem where the given function f of t is multiplied with an exponential, say e power at, and we need to find the Laplace transform of e power at into f of t. Now by the definition of Laplace transform, it is 0 to infinity e power at into, you have e power minus st f of t dt. Now this is equal to 0 to infinity e power minus s minus a into t f of t dt. So if the Laplace transform of f of t is nothing but f of s, so here instead of s you have s minus a. So therefore Laplace transform of e power at f of t, so Laplace transform of e power at f of t is nothing but f of s minus a. So when I multiply the given function f of t with e power at, you have to replace s by s minus a. Now similarly, if you have Laplace transform of e power minus at f of t, then it's going to be f of s plus a. So what do? You replace s by s plus a. So basically find the Laplace transform of f of t, and wherever s is there, you replace it by s plus a if f of t is multiplied with e power minus at. So this is referred to as the first shifting theorem. Find the Laplace transform of e power minus 3t into t power 4. So in such problems, first find the Laplace transform of t power 4. So Laplace transform of t power 4 is, of course we have to use this expression, isn't it? So it is n factorial, 4 factorial divided by s power 4 plus 1, which is 5. Now Laplace transform of e power minus 3t t power 4 is 4 factorial. So wherever s is there, that has to be replaced by s plus 3. So remember, if you have minus 3 here, it becomes plus 3, right? If it's e power minus 8, it becomes s plus a. So s is replaced by s plus a. So it is 4 factorial divided by s plus 3 whole power 5. Next problem. So find the Laplace transform of e power t into t plus 1 the whole square. So again you find the Laplace transform of t plus 1 the whole square, and then it is multiplied with e power t. That means wherever s is there, that has to be replaced by s minus 1 because a is 1 here. So we need to find the Laplace transform of t plus 1 whole square is t square plus 2t plus 1, which is, so what is Laplace transform of t square? It is 2 factorial divided by s cube plus 2 into 1 factorial divided by s square plus 1 by s. So now Laplace transform of e power t into t plus 1 the whole square is, wherever s is there, replace it by s minus 1. So it is nothing but 2 by s minus 1 the whole cube plus 2 by s minus 1 the whole square plus 1 by s minus 1. Find the Laplace transform of e power 2t sine 3t. So again first find the Laplace transform of sine 3t. What is the Laplace transform of sine 3t? It is of course a divided by s square plus a square. So a is 3, so it is 3 divided by s square plus 9. Now Laplace transform of e power 2t sine 3t. So here in this expression, what do? Wherever s is there, replace it by s minus a, which is s minus 2. So it is 3 divided by s minus 2 the whole square plus 9, which is 3 divided by, so it is s square minus 4s plus 4 plus 9, which is 13. So this is the answer. So find the Laplace transform of this expression. So let's first find the Laplace transform of 2 cos 5t minus 3 sin 5t. So Laplace transform of 2 cos 5t minus 3 sin 5t is 2 into, so Laplace transform of cos AT is s divided by s square plus a square. So it is s divided by s square plus a square is 25 minus 3 into a, which is 5, divided by s square plus a square. So this is 2s minus 15 divided by s square plus 25. So now we need to find the Laplace transform of e power minus 3t into 2 cos 5t minus 3 sin 5t. So what has to be done? So wherever s is there, you're going to replace it with s plus 3 because a is negative. That is, you have minus 3 here. So you have 2 into s plus 3 minus 15 divided by s plus 3 the whole square plus 25. So this is 2s plus 6 minus 15 is minus 9 divided by s square plus 6s plus 25 plus 9 is 34. So this is the answer. So find the Laplace transform of cos hyperbolic at into cos at. So now this is a hyperbolic function, this is cos. So what do we do? Replace cos hyperbolic function in terms of exponential. So I have cos hyperbolic at as e power at plus e power minus at divided by 2, right, into cos at. So this is 1 by 2 into e power at cos at plus e power minus at cos at. So now if I have to find the Laplace transform of this expression, what do we do? Find Laplace transform of cos at, and wherever s is there, replace it by s minus a here, and here replace s by s plus a. So we know that Laplace transform of cos at is s divided by s square plus a square. S divided by s square plus a square. So here I have 1 by 2 into Laplace transform of e power at, that means e power at cos at plus Laplace transform of e power minus at cos at. So this is 1 by 2 into s divided by s square plus a square. So here replace s by s minus a plus s divided by s square plus a square, replace s by s plus a, right? So now let me replace the value. So you get s minus a divided by s minus a the whole square plus a square plus s plus a divided by s plus a the whole square plus a square, which is 1 by 2 into, now s minus a the whole square is s square, right? And then you have minus 2as plus a square gives me plus 2a square, and numerator you have s minus a, and then you have s plus a divided by s square plus 2as plus 2a square, right? So now let me rewrite this expression. Now how will I rewrite this? Let me rewrite this as s square plus 2a square minus 2a. So s square plus 2a square minus 2as, and let me rewrite this as s square plus 2a square plus 2as. Now observe that the denominator is of the form a minus b. So this is a minus b, a plus b. So when I take the LCM, you get a minus b into a plus b, which is nothing but a square minus b square. So 1 by 2 s minus a into this expression. So you have s square plus 2a square plus 2as plus s plus a into this expression, s square plus 2a square minus 2as divided by, so this is a minus b into a plus b, which is a square minus b square, s square plus 2a square the whole square minus 2as the whole square, right? So let me multiply. You have 1 by 2 So observe, s into this expression will give me, this is s cube plus 2a square s plus 2a square s, and then plus 2a square plus 2a square, and then all these three multiplied with minus a. So you have minus a square minus 2a cube, right? And then minus 2a square s plus, so these terms I'll write it on top. So you have s into a square, which is s cube, plus 2a square s, and then minus 2a square, and then you have a square into a, and then you have a into 2a square, which is plus 2a cube, and then you have minus 2a square s. So this is the numerator, and then the denominator is a square minus b square. So squaring this, you get s power 4 plus 4s square a square plus 4 a power 4 minus 4. So again here this is a square a square. So observe what are the terms which can be cancelled. So plus 2a cube minus 2a cube, a square minus a square minus 2a square, these two will get cancelled. 2a square s and minus 2a square s gets cancelled. 2a square s and minus 2a square s. So you get 2s cube, right? So this is 2s cube divided by 2, and here these two terms get cancelled, right? So you get into s power 4 plus 4a power 4. So 2 and 2 gets cancelled. So the answer is s cube divided by s power 4 plus 4a power 4. So in this lecture we have seen what is the first shifting theorem. So this is the first shifting theorem where Laplace transform of e power at f of t is f of s minus a, and if you have e power minus at, it becomes f of s plus a. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.